Okay, so you can use Mathematica to basically do algebra for you and find solutions to equations when they're equal to specific values, okay? So here's the first example of that. The first thing I'm doing in this notebook is just clearing all the variables. So when I do that, a bunch of things go blue, which basically means I haven't defined them yet. And now I'm defining a new function, which is just x squared plus 4, okay? What I'm going to do with this guy here, actually I'm going to take this out for a second, is I'm going to try to figure out where this function, or what the value of x is when this function is equal to 0. So when f of x is equal to 0, what is x equal to? And the way that find root works, it's using a numerical algorithm where I have to give the program a initial guess. So it says, hey, let's find what x is when f of x is equal to 0. My initial guess, or where you should start, is x equals 2. So I'm going to run this, and I get an error. In fact, I can get rid of this semicolon, and I don't get anything out. I just get an error. Encountered a singular Jacobian. Try perturbing the initial points. So I'm going to plot this just to see maybe what's wrong. And notice when I plot the function, I find that, of course, this kind of quadratic function never crosses 0. So there is no point of x where x is equal to 0. So I've kind of sent the computer on a fool's errand. So that's an example where, of course, you can't find the solution to a function that does not exist. Let's go down here and find a solution that does exist, though. So for find root, okay, again, the syntax here is the function, and I could have just typed it in. I didn't have to define it. I can, if I want, just type it in like that. But this is a double equal sign. It's not a single equal, it's double. That's the syntax that has to be. So I'm going to find where this function is equal to 10. And now again, I'm going to set an initial guess. Get rid of the semicolon. And here you can see actually this does have a solution. And I can go look at my plot and kind of verify. It says this function is equal to 10 at about x equals 2.5. So somewhere around here. And that looks about right to me. Okay. If I want to make it more complicated, I can take that original expression that's the same as this, and I can say, okay, now find when it's equal to 10x. So that requires a little bit of algebra on the computer, but it can find that answer as well, okay? And again, you guys could easily solve this particular algebraic problem by hand, but here we're doing it on a computer. And there's reasons, obviously, for more complicated equations to do it on a computer. So what if I have a problem where I don't want a numerical answer, I want a symbolic answer, I want to answer with symbols in it. So let's do an example like that. So here I'm saying r, which is undefined, times x. I want to know when that's equal to s times 3x minus 5. And I want to solve this for x, okay? Again, you guys could rearrange this equation and solve it by hand. Mathematica can do that too. It says, okay, these things are equal when x is equal to this stuff. So notice it still has s's and r's in it. So that's symbolic math, okay? Here's an example where this particular thing, these two things can be equal to each other for several values of x, okay? So here it's giving you two possible solutions. So here, basically a plus or minus situation inside the parentheses. So this is a case where you'd want to just pick one solution or the other solution. Let's see if I can do that without. Yeah, here it's just giving you the second solution. So using this stuff in nested location is nested. This is called double nested format. It's kind of a pain in the butt, but I show you how to deal with it in some of these other notebooks. Go back and notice that this here is just a kind of math way of saying it where things are typed out as nicely as possible, but it still has fractions. So if I want a numerical version of that same answer, I can say, hey, give me a numerical version of the last thing you computed, and that's what I get here. And if I wanted to, I could do that in between these steps, and that gives me two numerical solutions. Okay, let's clear all variables and we'll start over again. If I want to solve a system of equations, let's say I had more than one equation, like we did in the lab for Kirchhoff's law. We had a big circuit we were trying to solve. Here I've got two equations, two unknowns, and Mathematica can solve this for both x and y. Okay, again, you guys could easily do this as well with some substitution. Obviously, Mathematica does it quite quickly. Okay, let's clear variables again. And let's do an example where not everything is defined. So instead of having 2 and 5 in here, I've got A and B. Okay, so that's a nice example of how you can use Mathematica basically to do algebra for you. Remember that not all equations like this, like relationships, have analytical solutions. So if you're finding that solve doesn't work, it maybe means that that's something that can't be solved, and you would need to use something like find root. And in find root, you cannot have undefined variables. In fact, let me just show you that. It's going to complain. So here, I can't use find root because A in this function is not defined.